Homework's due on Wednesday, is that right?
Sorry?
The homework is due on Wednesday?
No, Friday.
Oh, great.
Good morning, everyone. I am feeling little bit okay today, so that's after second shot actually I got fever and then I canceled my class. I thought that it's better to cancel the class, but now I am getting better. Now I posted some final exam practice problems. So in this set of questions you will see most of the conceptual questions. So in the exam you will have some questions, just I'll give you the data set, that means output, and you need to answer the question. So in this set of questions most of them are conceptual. Now let me talk about more details, the final exams. The final exams is cumulative, means you will have multiple regressions, ANOVA, ANCOVA, logistic regressions, non-parametrics, contingency tables. Chapter 13, actually you can see that chapter 13 is included in the multiple regression because you are just checking some assumptions. So you need to have this one. And the last part that we covered in the last class, non-parametric one. Okay. So you can think of the final exams is everything except this. Well, the final exam is longer than the midterm. The final exam, the timing is like same, 24 hours. The questions will be like couple of questions, of course, because this covers all the materials except the simple linear regressions. So obviously you can expect that there will be more questions than the midterm. Now, there will be some questions in the data analysis. So the reason I posted this sample questions because you need to be familiar with the conceptual questions. And we did lots of data analysis in every chapter, so you know how to do the data analysis and answer the questions. So the materials will cover almost everything. So you have enough time after our class, because our class will finish in next week, I think, the last class on Monday, and then you will have almost a week to prepare yourself for the final exams and go over all this. You can see that I posted many questions for every chapters, and we did lots of practice problems for every chapters. So you have your midterms questions, you have your class questions, you have your final exam practice problems. So this will be more than enough for you to prepare yourself for the final exams. Again, it will be take home, so you will get 24 hours to complete the exams. And I posted the homework for 5, and you can see the homework 5 is due this week on Friday. And you have also the project is due the May 5, I think. So you need to also work on the project. And I also uploaded here, if you go to the, where is the project on? Here, the sample project. So you can see what I am looking for in every topic. You have to give your introductions, okay? Objective research questions. You already know what is your research question that you are answering. Your data source and the variable descriptions. That's very important because you tell me, okay, this is our data, we got this data from this, blah, 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 and this is our variable that we are considering. Methodology and the reason for using this methodology. Why you are using this? Not only just you say that I am using the multiple regression, but why? Now, compact and the augmented models. Of course, when you are writing a models, you should have, okay, this is my simple models, this is my augmented models, hypothesis, okay, what you are testing. assumptions and the verification for the assumption for the proposed methodology. Okay, for example, if you are using multiple regression models, so you should write your assumptions and then you say that we verified this. Even if it is violated, that's, you can just say that it's violated, but we verified this. Okay, I want this should be in your report. Now then data analysis and relevant output from the jump. Not every single tables. I don't want every single tables. The one that you think that this is relevant. Don't put all these graphs in your project. It should be only a couple of, I already give you that how many pages, and the result and the discussions, model comparisons, that means augmented and the compact models and the conclusions. So this will be your guidelines for the project, that what sections should be included in your project. Any questions? Okay, now I posted one materials, we call it the indicator variables, or this is not in your book, but this is what you have to know. Sometimes we can have in our regression models the variables that are not quantitative. Okay? You know that we consider the variables that are not quantitative. In our regression, in our models, we call it the ANCOVA. We have quantitative and the categorical variables. But now, ANCOVA, we don't consider the quantitative variables as a predictor. We consider it as a covariate. Now, if we want to consider both quantitative variables as well as categorical variables, both of them are predictors, then it will be a multiple regression models. Okay? Now, there are many situations where we can have categorical predictor in our models. For example, if we want to know any categorical variables like the brand of a candy or the model of a car or month of bike ride or the type of bike ridden, there are many situations. So I consider a data set here, house selling prices data in JUMP. So if you go to the data set here, you can see there is one data set, house selling prices data. You can download this one, open this data in JUMP. Now if you look at this data, we are interested to predict the price of a house. Now we consider the variable that house size. You know, of course, the house size is the most important variables. So the price depends on the house size. There are many other factors, you know, age, bedrooms, bathrooms, whatever. Now we are considering another variables. We call it the garage. Okay, whether the house has a garage or not. Now you know that, of course, if the house has garage, obviously the price will be little bit higher compared to the house without any. Okay? Now, this is a categorical variable, so two categories. One means they have, zero means they don't have. Now, if we would like to consider these two variables in our models, now, look at these variables. This is, of course, this is a indicator variables 1 and 0. Now, this is not a quantitative variable. This is just a categorical variable with two different levels. Now, if we would like to include these two variables in our models, model fitting criterion is same. We can just run the models like this. Okay. Fit the models, house price, based on the size of the house, and they have the garage or house. And if you run this model here, you can see everything is there. We fit these models, we get these results and everything. Okay, now if you go back here, this is what I put it here. So we said that we have real estate listing data for a sample of 200 houses, and we'd like to predict the sales price of a house using the size of the house and whether the house has a garage or not. Okay? We feed the multiple regression models, we get this on. Now, in reality, if we have any categorical variables, we include it in the regression equation by creating the dummy variables, or sometimes called indicator variables. So this is actually in this 0, 1. So this is actually the dummy variable. JUMP automatically do it for us. Even if you look at this, this looks like the continuous, but it is actually the categorical variable, so two different levels. Make sense? Everyone? Okay, now. What is actually the indicator variable? The variables is a binary variable that reflects the level of a categorical variables in the data set. The indicator takes 1 if the level corresponds to with this indicator 0 otherwise. JUMP automatically do it for us. Okay? Now the question is that there are two values for whether a house has a garage or not. Do you need two indicator variables? What do you think? Do you need the two indicator variables? You have to fill it up. I just ask you the questions. We have two values, whether a house is a garage or not. So how many indicator variables do you need? So could the variable take the different values like 1 and 5? Yes, it can take. You can just put, this is just, we call it the dummy variables, either 0 or 1. You can put any number. It will not change anything. But when you are interpreting, you have to say like this. Okay, now, the question is that, how many indicator variables do we need? If we have only two levels, one variables. If we have three levels, we need two indicator variables. So this is what we just mean by the how many variables so do we need. So you can just say we need only one indicator variables. Now, let's look at the model when using the first indicator variable to indicate the house has a garage. When there is a garage, what will be the models? Okay, look at this. How can we write these models? Okay. So y equal to, we know that this is what we have, beta 0 plus beta 1 x1 plus beta 2 x2 plus epsilon I. Okay? Now x2 is an indicator of variables, okay? Either 0 or 1. So 0 means no garage, 1 means yes. Now you can easily write the models. Is that clear? How can you write the models? Now you can easily write, okay, we actually did this one in our test one, that okay, the full suspension and not suspensions. So here is the same situation. So you can write your models in terms of this. Now the question is that what does it mean when we include these indicator variables in this model? So we'll have the prediction equation based on this. So if we want to write down the prediction equation based on these models, how can we write these prediction equations? So the predicted value of the house price is equal to, this is our intercept, this is our slope for house size, and this is our slope for the garage. Now how can you interpret this slope? Can anyone tell me? Let's say if I want to interpret the slope of the house size.
For every increase in $1,000, there's an increase in 0.06 square feet.
So for every 1 square feet increase in house size, because house size is the square feet, okay? The predicted price increases by this amount. That means you need to multiply it by $1,000. Okay, so you can say 67.43 dollars after adjusting for the effects of the garage in the model. So we can say the predicted house price increases by $67.43 per additional square feet of the house after adjusting for the effects of the other variables in the model. Because we have another variables which is garage. But now tell me, how can you interpret the garage?
There's an increase in price of the house of $4,000 if there is a garage or if there isn't a garage.
Okay. Now, the average price or the predicted price of a house is $4,000 higher for the house with garage than the house without garage, after adjusting the effects of the other variables in the models. So we can see that predicted house price, because here the JAMP automatically considered the lower levels as a reference category. So here we have the 0 as our reference category, here the no, so that the predicted house price increases by $4,000 for the house with garage than the house without garage, after adjusting the effects of the other variables in the models. Or we can say the average house price for the house with garage is $4,000 higher than the house without garage, after adjusting the effects of the other variables in the models. Yes.
So the dummy variable, the garage, is that's a categorical variable.
Yes.
Why is this not in covariate?
Why it's not?
Because wouldn't house size be the covariate and then garage would be categorical?
That's why we are saying that in ANCOVA, we would like to, that's the purpose is different. What we do in the ANCOVA we consider only predictors as our categorical variables. The predictor is our categorical variables. The continuous variable that we consider, we don't consider is a predictor, it's just a covariate. But now we are considering both of them as our predictors.
Oh, okay.
So that's the difference in the ANCOVA and when we have multiple regression with categorical predictors and the response variables. So how will the interpret the two categorical variables if Y is log price? What do you mean by log price? X2 categorical variables, if Y is the log price. So you just need to say that the predicted log price, and then if you take the e to the power of the log price, you get the price. So this is how you get the price. So why you need to know the log price? Log price is only when you have transformations, okay? Otherwise you are not taking the log price. So we take the transformation, then we get the log price. So log price in terms of the log, you can just say, instead of you can say the predicted price, you can say predicted log price. Or you can, if you want to express it in terms of the price, then you have to say e to the power this. This will be in terms of the price. Is that clear? Okay, now this is what we just need to know here, that when there is a garage, what will be our model is, what is the prediction equation is, and you know how to write it down. So your model will be like this. So here you need only one, because you have two categories, so you need one. When there is a garage, the model will be y equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus epsilon I. Now x2 we already know that x2 is 0 and 1. So here in this case the model will be like when there is a garage, so it will be beta 0 plus beta 2. This will be your intercept plus beta 1 x1 plus epsilon I, because x2 is equal to 1, okay, when there is a garage. Now prediction equations, you know that you plug in x2 equal to 1 and all these variables values are given here, okay. Now if you want to write down the prediction equations, you just go above and you can see what is given to us. The predicted value of y hat, and then you plug in the values of intercept and the slope and the other things you can see here. This is what you need to plug in, 64. Point 66, 0.067, okay, x1. Now 40.29, and x2 is 1, so you can just plug in here 1. So this will be your predicted equations when there is a garage. Now similarly, you can do the same thing when you don't have garage here. If you don't have garage, so you can just write it down that, okay, x2 here is equal to 0, because we are saying that 0 means there is no garage. So your model will be just beta 0 plus beta 1 x1 plus epsilon I. Okay. Now you can just write it down, this beta 0 plus beta 1 x1 plus epsilon, and then you plug in these values. So this will be 0 here, so you just get this one. Okay. So you learn how to interpret the values of slope for each of the cases. Whenever we have the indicator variables, we are just looking at this interpretation of the slope as just like if we change the labels for one category to the other category, what is the average change? So we can say that the average price of the house is $4,000 higher than the house with garage compared to the house without garage. Or we can say the average price for the house with garage is $4,000 higher than the house without garage after adjusting the effects of the other variables in the models. So you have to say that after adjusting the effects of the other variables in the models. So you can see what we can do here now. Now here we put the regressions models like house price in $1,000, okay, and the house size, and we get the two slope because we have the two regression equations. So this is the difference between V0 and V2. So here, if you go back, now one thing you can notice, let me see, where is our graph? So we get only one graph, because we have only one predictors here. So if you go and check this one, make it categoricals, then you can see that, and if you fit the models, house price versus this, and the garage. So you can see that they are very parallel to each other. We don't see any differences here. And actually we don't see anything here. So that's kind of weird thing, why you should get this one. Make it continuous. That shouldn't be. We already got this one. Okay, let me just the house price. With the models with the house price, and what I did here, house price in thousands and the house size. And house size. Oh no, here HP in thousands. HP in thousands. Remove this one. House size here. And if we put this one here, pretty good. We're doing the same thing. And if I just do HP and house size. Okay. So here I wanted to show this difference. Is this reasonable? So linear feet for garage and no garage. House price in thousands. And let me check what, when we fit these models at the beginning, this is our 109, the same thing that we got it. Okay, 252, 80. Yeah, everything is same. Yeah. So this is what we got it. Now if we fit a linear models, don't see anything like, what is it? Does it make sense to run a models with house price and X2 whenever the house has a garage, and I mean without X1? Then it will not be ANOVA. So it will not be like regression models. So if you just use the categorical predictors, then it will be just ANOVA. You have learned already what is ANOVA. Okay, now that's actually I just wanted to discuss, nothing else. So I think that's fine. This part, the interaction effects is, I just include the interaction effects, and let me show you that how we can include the interaction effect here. So let me, okay. House price based on house size and the garage. Now the interaction between these two. And you can see that this is what I run it, because the interaction effect is significant. Now, what does this interaction effect tells us? This is another one. If the interaction is significant, what does it mean?
That garage and house size work together to predict the price of the house.
Okay. Now, what does this value tells us? Can anyone tell me? When I get an interaction term is 61.86, what does this value tells us? And it is significant. You already know the main effects, you already know the main effects of house price, house size and the garage. But if we have the interaction effects, so that means if we change the levels of one variable, the prices, average prices is changing. Okay? Now for every 1 unit or every 1 square feet of house is, when we increase this, the average house prices increases by this when we have no garage or when we have the garage. Okay? Now when we have the garage, this is increasing. than when we don't have the garage. So we can see that there is a significant difference in this. Unit increase in size, that means per square feet, and the presence of garage will increase the house price by $6,000 or $6,000. Yeah, you are right. So this is what I mean by this. Like when we have the per square feet increase in house size, and when the house has the garage, the average price of the house will increase by or higher than $6,000 than the price of the house without garage. So we can see that interaction means when you change the levels of one variables, the price of the other variables are changing. So this is called the interactions. So you can see that already you can see the interpretation is here. Can you see the interpretation that Priyanka wrote it down in the chat? So this is the same thing. You can just write it down here that for per square feet increase, house size. Increases or the predicted price with the house with for the house with garage is $6,000 higher than the price of the house without garage. So the per square feet increasing, or you can say that predicted house price for the house with garage is $6,000 higher than the price of the house without garage, per square feet increase in house size after adjusting, another important thing, after adjusting the effects of the other variables. The model. Okay, so that's all about our indicator variables and the description of this. What does it mean? How to do it? Now, let's do so this is our formal lectures for this course. Now we can do some class questions, what is called final exams review questions. So if you go to the ELC, you can see that there is the final exams questions, so please open these questions for us. Okay, now this is from the test 1 materials. Like I have information about 74 cell phones from which I have obtained the common specifications. For now, I want to predict the talk time in minutes using the battery capacity. Okay, now describe this scatter plot. What can you see in this scatter plot? If I want to describe this, the scatter plot, how can I describe? So we can see there is a positive association or correlation between the battery capacity and talk time. Okay, but it is not so strong because the points are more scattered. So we can see there appears to be moderate, positive, linear relationship between the talk time and the battery capacity. Of the cell phones in the sample. So we can say as the battery capacity increases, the talk time also tends to increase. The most important thing here, when I ask you that describe the scatter plot, the most important thing you need to know whether there is a positive relationship or negative, whether there is a strong relationship or weak relationship. And you can just talk about how strong, we don't need to, just whether there is a strong relationship or not, or weak relationship. So weak positive relationship, yeah. So this is what I mentioned, that you can either say the moderate or weak. It depends on, like, we don't know exact value, so we can just talk about like this. Now, would the model comparison you would use to address whether the battery capacity is a useful predictor of the, what would be the model for this one? If you would like to address whether battery capacity is a useful predictor of talk time, and define all the terms in the augmented model. So we'd like to know our models. Okay, so model C, yi, sorry, equal to what?
Beta 0.
Beta 0, okay, plus epsilon I. So you have just simple models. So this is our model C. Now model A.
There's just the one predictor, right? So beta 0 plus B1 X1.
Plus beta 1 x1 plus epsilon I. So this will be our model A. So yi equal to beta 0, beta 1, sorry, beta 1, xi1 plus epsilon I. So this is our model A. Okay, so we get our model C and model A. Now find and interpret a PRE for the model comparison you outlined or identified into using the output provided. So output is provided at the end. Okay. So what is our PRE and the F? How can I find it out?
Theories are squared when
Okay, so R square is our PRE. So R square is given, and F. So we did I ask you just PRE or F both? So no, just PRE. So the PRE here is R square because this is we are comparing the. So PRE is equal to R square, And what is our R square here?
9%.
9%. So we can just say 0.094502. 0.094502. Okay. What does it mean?
It's not a good model.
Okay. How can you interpret this value? So I said that interpret this PRE. So this is R square. So how to interpret R square?
It's 9% better than the compact model at predicting problem.
R square is called the percentage of variation. Okay? So we can say 9% of the variation in Y. What is our Y here? Talk time. Okay? So we can say the 9% variation in talk time can be explained by the model on the basis of battery capacity. Okay? Now this is not a good model. Now, yes, yeah. So the variation in Y can be explained. So we can see percentage of variation, which is actually the 9%. So we can say 9% variation in Y that can be explained by the battery capacity, or 9.4%, or whatever you just said. Maybe 9.4 is good. Here we can say. Now the next thing is how can we write it down? So this is what we can say, that 9% variation in the talk time can be explained by these models. So this is not a good model. So what do you conclude regarding the model comparison you identified in 2? How can we conclude this one? We don't know our p-value, we don't know our f, but can we make a conclusions? Do you know this? Is there any way to make a conclusions? We have a table. So do we know our table? We know our table. So go to the table here that we have seen earlier. Okay? So tables for PRE and DF. So if you go back here, so which one we should use? The table A1, because PA minus PC equal to 1. Okay? N minus PA. What is our N minus PA?
77.
So N is 74 and PA is 2. So 72. So we go to the last one here. You can see 60. Okay. Now what is our PRE? 9%. So it's between these two values. Is that right? Now corresponding p value 0.01 to 0.025. Okay. Now this is how we get our p values from table A1. Is that clear for everyone? Now you can write it down from there is a p-value between 0.01 and 0.025, okay, which is less than significance level of 0.05, okay. So we have significance. Sufficient evidence to reject the compact model. So if we reject the compact model, what does it mean? The battery capacity is a useful linear predictor of the talk time predictor DIC of mobile phones. Okay, so we get this one. So what would happen to the PRE? If we are to include another variable, say the storage time as the predictor,
It would increase.
either it could increase or it could stay the same. We don't know. So we can say either it could increase or stay the same.
Depending on what the variable.
Yeah. So if you look at this, when we include the storage time, and because this is also, we have the storage time and the battery capacity, the size, we include more predictors. But if we include the one, so we can just say that in general that it would either increase or stay the same. The PRE would stay the same or increase. Okay, now the next thing. Now I have a lot of specs, so I might as well use them. Starting over, I now want to know if the overall model that includes all the variables below is better than a simple models. So what is our new augmented models? What do you think? The new augmented model.
You go to B4 X4.
Okay, so we go to the yi is equal to b0 plus b1 x1 beta 2 x2, so beta 3 x3, then we have another variables. So this is called the multiple regression models actually. Beta 4 x4 plus epsilon I. So yi, yes, is equal to beta 0 plus beta 1 x I1 beta 2 I2 3. Plus epsilon I. So this will be your augmented models, where x1 is the size, x2 is the S1, and you can just describe what is x1, x2, and x3, and x4. Now interpret the estimate indicated in this output. Okay, what is our output here? How can we interpret this? So for example, if we just consider the storage, what can we see? As the storage increases by 1 GB, okay, the predicted talk time increases by 5529 minutes when after adjusting the effects of the other variables in the model. So we will continue, our time is up, so we will continue like this in the next class, and hopefully we'll finish all these things in these 3 classes. And for the final exam, please do lots of practice, then you should be fine. Any questions? Those are online. Could you upload the today's answer? For which one? Even this one, because this is one file. I already uploaded all these things, but this file I will upload the answer because at the end when I will finish this one. I didn't finish this one now. So hopefully this one will upload at the end of the class. Any other questions?